Let's have a look at this blending or averaging route sector winds for flight planning. So the situation arises when you have a flight plan that covers multiple weather subdivisions. So I've set up a bit of an example here, a track of 090, a weather change at halfway. In the first half of the flight, we have a northerly at 20 knots, and in the second half, we have a northeaster at 60 knots. So the temptation is to try and blend or mathematically average these winds so that we can run a single line of cruise in the flight plan and save a stack of time. So let's try and do that. One method is to linearly interpolate like you would any other data in the exam. So let's get 1 degree and 50 degrees and average that. 1 add 50 divided by 2 gives 25.5. Let's call it 26, 0.26 degrees. Do the same with the velocity, 20 knots and 60 knots. Gives 40. And it appears right. We know that the wind must be somewhere between the north and 50 degrees. 26 is about halfway. 40 knots is half the strength. So it seems like it should work. But if you try a few of these, we know it doesn't. And it's easy to see why if you push it to a more extreme example. So let's change the wind to 090 at 60 for the first half of the flight, which is pure headwind. And in the second half, we'll change it to 000, keep the velocity the same. Draw the vectors on just so we can keep a bit of situational awareness. So if we were to mathematically average them like we just did before, 90 degrees and 0 degrees would be 0.45. And 60 knots and 60 knots would average out to 60 knots as well. But if we look at it a little bit longer, we can see that wouldn't be the case. In the first half, we have a pure headwind, which is a pure 60 knot wind component. But in the second half, it's entirely crosswind. So that would produce a 0 knot wind component. So the real answer would be somewhere, when we're talking velocity, the real answer would be somewhere between 60 knots and 0 knots as an overall wind component. So really it should be somewhere around the 30 knot mark, not 60. So I found something that's quite interesting. If we get this example and plug it onto a whiz wheel, 90 degrees at 60 knots, we mark it here, and 0 degrees at 60 knots. If you scribe a line between them, and split that line halfway, we get a resultant of 30 knots, which appears to be correct. So does this method work? Can you just plot the two on the whiz wheel and split the line at the halfway mark? Well, it doesn't even have to be halfway. We can make another example. Let's keep the same numbers as the original one. Track of 090, a wind of 001 at 20, and 050 at 60. But this time let's make it a 75-25 split. So we'll say that the northerly wind is dominant. So if we calculate them individually and get some ground speeds the traditional way, we have 1 degree at 20 knots, and a track of 090, which is entirely crosswind. So let's say that's a 0 knot wind component. So we're doing 400 knots still. So 400 add 0 is 400. And for the second wind, we have 50 degrees at 60 knots. track of 90 gives us 45, let's say 47, minus a bit of ETAS, 40, so say minus 46 wind component. Gives a ground speed of 354. So let's run those ground speeds the traditional way individually and see what the total time is for the whole trip. So we got 400 knots for, let's give this some figures, 300 nautical miles, 100 nautical miles. So let's say 400 knots for 300 miles is 45 minutes. And we'll run 100 miles at 354, so 355, 54, be somewhere there for 100 miles is 17 minutes. Gives a total of 62 minutes. Now let's try this new way of blending the winds together. So I've got them plotted there already on the whiz wheel. Scribe the line between the two. Now this time it's not a 50-50 split, so we have to change where that slider lies. So it might seem a little bit counterintuitive, but we have to favour the dominant wind. So our little slider has to be closer to the northerly wind. So it's still a 3/4 split, but it's sort of like flipped around. So I'll put the slider at about 3/4 closer to the dominant wind. And we read off an average or resultant wind of 027 degrees at about 27 knots. So we'll say there's the whiz wheel equals 027 at 27 knots. So let's try and run that for the full 400 and see if we get anywhere close to the answer. So 027 at 27 knots, a track of 90 degrees, gives us 10, 15, let's call it 12 knots of headwind component. The crosswind is 20 at 400 knots, gives us no ETAS, so 400 minus 12 equals 388. So that's our average ground speed based on the average winds of 388 knots. If we come over here, 360, 70, 80, 388, it's about here. So 388 knots ground speed for 400 miles gives us 62 minutes. Which is the exact same answer.